Alright class, in this video we're going to talk about special right triangles. Specifically, we are going to talk about the 45, 45, 90 special right triangle. And so we know that this angle is 45 and this angle is 45. So, things to note about this is it is actually an isosceles right triangle, which means the legs are always the same length. And so in this video, I want to show you first the proportions method for solving these triangles, and then I want to show you the Pythagorean theorem method for showing these triangles. I'm not going to show you guys the tricks because those are just something you memorize and pump back out. And so let's get started with the reference triangles, that smallest triangle that we're going to use to set up our proportions. So our reference triangle for this is 1, 1, square root of 2. This is the triangle we will use to set up the proportion. Both of the legs are 1 and the hypotenuse is square root of 2. So let's look at an example. Alright, so let's look at this problem. We are given one leg as 3, and we need to find the other leg and the hypotenuse. So right away, I know that this other leg, x, is also going to be equal to 3. With the 45, 45, 90, the legs are always the same. So whenever you're given that, easy points right there. The next thing that I would like to do whenever setting up proportions is I will draw my reference triangle in the same orientation as the given triangle. So I will draw a reference triangle right here, same orientation, just right off to the side of my given triangle. And then we'll label the sides of our reference triangle 1, 1, square root of 2. And then I will begin to set up the proportions. So I will set up my proportion and I will say 3 over y is equal to 1 over the square root of 2. Now it does not matter if I did 3 over y or if I did y over 3. The only thing that is important is that our leg here matches up with our leg on our reference triangle. And our hypotenuse matches up with our hypotenuse. And so here we had leg matching up with leg. We will need to do hypotenuse matching up with hypotenuse. So now that we have this problem, we will cross multiply and solve. And so I will cross multiply and solve. So I'll do square root of 2 times 3 is 3 square roots of 2. And y times 1 is y. And there we have our solution. Y equals 3 square roots of 2. It is as simple as that. But of course, because I'm mean, I do not give you all problems that are as simple as that. So let's look at something a little bit more complicated here. Alright, so here's another problem. The orientation is different, so I need to draw my reference triangle differently. I need to make sure that it looks the same as the other triangle. Once I have that, I need to label my legs 1, 1, square root of 2. And now I'm ready to set up my problem. So I will say that, stupid McAfee. I will say that u over 6 is equal to 1 over the square root of 2. Cross multiply and solve. So I will cross multiply and I will say that u square root of 2 is equal to 6. So I'm going to actually come over here to solve that. And so I will say that u square root of 2 is equal to 6. Now I need to solve for u, so I divide both sides by the square root of 2. those cancel out, and I'm left with u is equal to 6 over the square root of 2. Now we said that is both crude and vulgar, to quote Mr. Warner. We cannot leave square roots in the denominator, so we need to get it out. And the way we do that is by multiplying by a clever form of 1, which is the square root of 2 over the square root of 2. That will become 6 square roots of 2 over 2. And so u will simplify even further, and we will say that is 3 square roots of 2. And so we knew that u is now 3 square roots of 2. And so we automatically know v is also 3 square roots of 2. Alright, let's look at one more problem that is even worse than this, and I'll pull it straight off our old quiz. And let's look at this. So here we have 3 square roots of 5 as one of our legs. And I know you guys just hate radicals. And because I'm a big meanie, there will be problems like this on your test. So it's good that you're watching this video and learning how to do it now. So again, just like before, draw a reference triangle in the same orientation as the picture that you are given. Then we'll label our sides 1, 1, and square root of 2. So just like all 45, 45, 90s, we automatically know this other leg is also 3 square roots of 5. Now we will set up our problem, and I will say our leg over hypotenuse is equal to our leg over our hypotenuse. So we will say 3 square roots of 5 over x is equal to 1 over the square root of 2. Just like before, cross multiply and solve. And we will get 3 square roots of 5 times the square root of 2 is equal to x. So whenever we have a square root of a number a times the square root of a number b, this is the same as taking the square root of a times b. So here we have 3 times the square root of 5 times 2, so 3 square roots of 10 equals x. And that is our answer right there. And that is how you do this with proportions. So now let's look at how to do this with Pythagorean theorem. Alright, so we will need to recall that the Pythagorean theorem is a squared plus b squared is equal to c squared, where c is our hypotenuse. So when we say this, we know that our legs are going to be equal to each other. And so let's just go ahead, instead of saying y, let's lightly cross that out and put x. So once we solve it, we know that x and y will be the same. So we could set this up where we will say x squared plus x squared is equal to 6 squared. X squared plus x squared is 2x squared is equal to 36, which is 6 squared. Divide both sides by 2, and we get x squared is equal to 18. Take the square root of both sides, and we will get x is equal to the square root of 18. That is the same as the square root of 9 times 2. So x is going to be equal to 3 square roots of 2. Some of you really like this method. It's a solid method. It's probably the method that I did in high school because I was not great at trig. So let's look at another problem though to make sure you got it down. Alright, so here we have 8 square roots of 2 as the hypotenuse, and we need to find a and b. Just like before, I'm just going to scratch out one of these and lightly put a. On the test, when you answer it, you'll actually need to put b equals as well, but in order to set the problem, it's easy to see that both of those are a. So I'll set up the problem again, and I'll say 8 square roots of 2 is equal to 8 squared plus a squared, and that is squared. Now, where a lot of people go wrong is when they type in 8 squared root of 2 in the calculator, they do not add the parentheses. And what happens when you do that is your calculator thinks you are only squaring the square root of 2, and so you'll get 8 times 2, which is 16, and that is not the correct answer. Instead, what we want is to add it in the parentheses. So when we type this into our calculator with the parentheses, instead of getting 16, we get 128 is equal to a squared plus a squared is 2a squared. Divide both sides by 2, and you'll get the 64 is equal to a squared. So the square root of 64 equals a, or 8 equals a. So on your test, when you finally write it down, you need to say a is equal to 8, as well as b is equal to 8. That is your final answer right there. Alright, so that's all I'm going to show you in this video. I hope this helped. Good luck on the test.